Okay, so here I would like to discuss the absolute value properties with inequalities. With absolute value absolute value inequality properties. And probably should have inequalities there. Okay, so before I do that though, let's discuss what absolute value means. And so basically, absolute value is a way to come up with distance. Basically, how far are so in other words, absolute value, right? So that's a symbol means the distance, how far a number is from zero. And so for instance, if this is say 2 here, then the distance here can be represented as absolute value of 2. Of course, that just means it's 2. However, a number over here, say -5, that would have a distance of absolute value -5, but really it's 5. That's how far. It's 5 units away from 0. Okay, and so that's what absolute value means. It means how far a number is from 0. And so let's discuss this properties here, which says that for a positive number a greater than 0 and an algebraic expression x, we have the following. Okay, so it says if we have the absolute value of x is, let me back up here. Keep in mind, x is an algebraic expression, so it can look like this. For instance, that's an algebraic expression. 3 minus x, that's an algebraic expression. So x is more than just a single term. It is an algebraic expression. And so we're saying the absolute value of an algebraic expression less than a is equivalent to minus a less than x minus a. Likewise, the absolute value of x is greater than a is equivalent to x less than negative a or x greater than a. And I want to explain where these properties come from. I'll give you some intuition about that. And of course, we could replace the less than or greater than symbol with less than or equal and greater than or equal to a as well to say similar things. So let's take a look at a concrete example. Suppose we have the absolute value of x is less than 2. And let's think about that. Okay, and so we know that here's, say, 0, 1, 2, 3, 4, say 1, 2, 3, -4. All right, and so let's think about that statement there. Okay, so then we want all numbers that are less than 2. Now, of course, where are the numbers that are equal to 2? Well, equal to 2 would happen at either be 2 distance away, right? And exactly at 2, right? But of course, this is strictly less than, so I would not include 2, and also at -2. -2 and 2 would be exactly 2 units away from 0. However, any number that falls in between -2 and 2 also has an absolute value of less than 2. And so, in other words, we need to, any x or expression has to satisfy that it is less than 2 and that it's greater than 2. In other words, -2 is less than x and x is less than 2. It has to be in between there, right? So any number between -2 and 2 would work there. And so another way of saying that is -2 is less than that x, and that x has to be less than 2. And that's where that property basically comes from. Likewise, if you have the absolute value of x greater than 2, the same idea, well, we know exactly where it's equal to 2. That would happen at -2 and 2. But now think about the numbers that satisfy that. Well, first you have the numbers that are way beyond -2 on the left side over here, going this way. And so that means x has to be less than -2. But, or they don't have to be less than -2, they could also be on the right side of +2. And therefore you get x is greater than 2. And so you can see that's why these statements imply that properties there.